to the tutorial. IUPAC, naming change. Let's begin!
During this last stage, we have listened about the IUPAC, but we don't know what it is or what it does. Firstly, if IUPAC does not exist, all the compounds and elements do not have a name. So, with this information, we can know that IUPAC is an organism in charge of naming all the chemical compounds. So, for this reason, the hydrocarbons are dominated in alkanes, alkenes, alkynes, and aromatics. So, thank you, International Union of Pure and Applied Chemistry! And maybe we have asked us why the hydrocarbons are called of this way. It is notorious that the IUPAC is full of imagination when are classifying them. So, we mean alkanes, alkenes, and alkynes. Only the difference is in the aromatics. But why is it important to name them? Well, it's important to have rules as the ones that we have seen, because there are a lot of hydrocarbons, and as Adam named all the animals that we know, also the IUPAC named these hydrocarbons with several requirements, as the quantity of carbons, the ramifications, the amount of bonds, etc., 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 with the purpose of knowing them in an easy way.
Hydrocarbons are the simplest organic compounds, containing only carbon and hydrogen. They can be straight chain, branch chain, or single molecules. Carbon tends to form 4 bonds in a tetrahedral geometry. Hydrocarbons that have 4 bonds to every carbon atom are called alkanes. These are the least reactive of the hydrocarbons. Cycloalkanes are alkanes in which the carbon atom join to form a ring. The smallest cycloalkane is cyclopropane. Hydrocarbons that have a double bond between 2 carbon atoms are called alkenes. These are more reactive than alkanes. Hydrocarbons that have a triple bond between 2 carbon atoms are called alkynes. These are the most reactive. Aromatic hydrocarbons are those which contain 1 or more benzene rings. The name of the class comes from the fact that many of them have strong, pungent aromas. Benzene is an important organic chemical compound with the chemical formula C6H6. The benzene molecule is composed of 6 carbon atoms joined in a ring with 1 hydrogen atom attached to it.
In organic chemistry, an alkane is a hydrocarbon in which the covalent bond between the carbon atoms is very strong, allowing the carbon atoms to form long, stable chains. In alkanes, all the carbon-carbon bonds are single. The IUPAC nomenclature for alkanes is based on identifying hydrocarbon chains. Unbranched saturated hydrocarbon chains are named systematically with a Greek numerical prefix denoting the number of carbon and the suffix "ane". In order to name alkanes, you should follow these steps. First, identify the longest carbon chain. That chain is called parent chain. According to the number of carbons that the parent chain has, is how you are going to name the hydrocarbon. The names are shown in this table. Then you have to identify all of the substituents that the hydrocarbon have. The substituents that the hydrocarbon can have are methyl, ethyl, propyl, isopropyl, isobutyl, sec-butyl, and tert-butyl. Next, you have to number the carbons of the parent chain from the end in order to give the substituents the lowest number. If the same substituent occurs more than once, you have to put the location of each substituent. In addition, the number of times the substituent group occurs is indicated by a prefix D, 3, etc. If there are 2 or more different substituents, they are listed in alphabetic order using the base name. You have to ignore the prefix. One important thing to know is that if chains of equal length are competing for selection as the parent chain, then the choice goes in series to A. The chain which has the greatest number of side chains. B. The chain whose substituents have the lowest numbers. C. The chain having the greatest number of carbon atoms in the smaller side chain. And D. The chain having the last branched side chains. 7. A cyclic hydrocarbon is designated by the prefix cyclo, which appears directly in front of the base name. It is important to remember that on an alkane chain, the halogen is treated as a substituent. The halogen substituent is considered of equal rank with an alkyl substituent in the numbering of the parent chain. The halogens are represented as follows: fluoro for fluorine, chloro for chlorine, bromo for bromine, and iodo for iodine.
In this example of alkane, first identify the parent chain. Name it according to number of carbons. In this example, there are 6 carbons. For this, it will have the preposition hex and the ane ending, forming the name hexane. Numerate it in order to give the substituents for lowest number. Then indicate where the substituents are. Write it in front of the alkane. With this, there is formed the 3-methylhexane. Alkenes are hydrocarbons that contain a double bond between carbons. It is formed when adjacent carbon atoms share 2 pairs of valence electrons. The general formula is CnH2n. If we have substituents in the alkene, first identify the name of the longest carbon chain that contains double bond. There are 7 carbons in the parent chain. It means that the prefix will be hept, and with the in ending, the name is heptene. Then, number the carbon chain starting from the end near the double bond. Place the number of the first carbon in the double bond in front of the alkane name, 2-heptene. Next, give the location and name for each substituent in alphabetical order as a prefix to the alkene name. There are an ethyl group in the 5th carbon and a methyl group in the 4th and 2 in the 6th. For this reason, the name is 5-ethyl 4,6,6,3-methyl 2-heptene. Alkynes are hydrocarbons that contain one or more triple bonds between carbons. The triple bond forms when 2 carbons share 3 pairs of valence electrons. The general formula is CnH2n-2. For naming alkynes, first name the longest carbon chain with a triple bond. It will depend on the number of carbons. In the example, being 5 carbons, it will have the prefix pent and the ine ending, forming pentyne. Next, number the carbon chain starting from the end near the triple bond. Place the number of the first carbon in the triple bond in front of the alkyne name, forming 2-pentyne. If we have substituents in the alkyne, first identify and name the longest carbon chain that contains the triple bond. There are 5 carbons in the parent chain. It means that the prefix will be pent, and with the ine ending, the name is pentyne. Then, number the carbon chain starting from the end near the triple bond. Place the number of the first carbon in the triple bond in front of the alkyne name, 1-pentyne. Next, give the location and name for each substituent in alphabetical order as a prefix to the alkyne name. There are an ethyl group in the 3rd carbon and a methyl group also in the 3rd. For this reason, the name is 3-ethyl 3-methyl 1-pentyne. An aromatic compound is a hydrocarbon that contains the ring structure of benzene. Aromatic compounds received their name because many compounds with benzene had fragrant odors. The general formula is C6H6G. When benzene has only one substituent, the ring is not numbered and only is written the name of the substituent and the word benzene. For example, we have the methylbenzene. When there are 2 substituents, the benzene is numbered to give the lowest number to substituents. Then, write the substituents alphabetically. First, write the position of substituents, then the name of them, and the ending benzene. In this example, there is an ethyl group in the first position and a methyl group in the second, forming a 1-ethyl 2-methylbenzene. There are prefixes that are used to show the position of 2 substituents. The prefix ortho indicates 1-2, meta indicates 1-3, and para is used for 1 and 4. Like the aromatic compounds with 2 substituents, when there are 3 or more substituents attached to the benzene ring, they are numbered in the direction to give the lowest set of numbers and then name it alphabetically. In this example, there is an ethyl group in the 4th position a propyl group in the first position and 2 methyl groups in the second and 5th position. All of this forms the compound 4-ethyl 2,5-dimethyl 1-propylbenzene.
In modern society, hydrocarbons are very important. This is because a lot of things. For example, hydrocarbons are the primary source of energy of current civilization. Also, a lot of medicines and materials that are used today are synthetic products of hydrocarbons.
Now, with this information, I can name any hydrocarbon. And with these steps, I am sure that you can do it too. It doesn't matter the size of any hydrocarbon. With these tricks and skills, we can name any of them. I am so proud and happy because I have advanced in my chemistry knowledge. And I know that also you can do it.
Although petroleum has now found many alternatives, the knowledge about this substance is still useful to facilitate the daily life.
Hydrocarbons are composed of carbon and hydrogen atoms. They are divided into 4 groups that are alkanes, alkenes, alkynes, and aromatic hydrocarbons. You can find them in every organic compound, such as human, plant, or food.
In organic chemistry, to name hydrocarbon, it's necessary to strictly follow the rule of the IUPAC system, which allows to identify the belong of each one between the already learned groups, alkynes, alkanes, alkenes, and aromatic compounds. IUPAC allows hydrocarbons to be formulated by naming them.
We think that all these rules made by IUPAC are important to know all the hydrocarbons that exist in our world. The rules are easy to understand, and with them we are able to name any hydrocarbon that will be in front of us. And it is a great and important part of chemistry to know them because they are in our surroundings and sometimes we do not appreciate them. So, thank you to the IUPAC and the organic chemistry, we are now experts naming hydrocarbons.